Okay, we're going to be going over empirical and molecular formulas. You do need a calculator and a periodic table. On this first part up here, we're going to be able to identify if it's an empirical formula or if it is a molecular formula. One way I remember this is the empirical formula is simplified, meaning it's already reduced. It can no longer be reduced in terms of the subscripts, the little baby numbers. A molecular formula is not already reduced. It's not simplified, meaning you still can reduce it. Usually those numbers are a little bit bigger. So we're going to go through these. It says circle the formulas below that are empirical. Again, so it wants us to circle the ones that are already reduced. So as we're looking right here, C2H6, is this reduced? No, it's not reduced. So that's considered a molecular. CaCl2, is that reduced? Can it get any smaller with the subscripts? No. So we're going to circle it. KMNO4, empirical or molecular? It's going to be empirical. We cannot reduce it with anything. H2O2, can this be reduced? Yes, so that is considered molecular. H2F2, is that reduced? It can still be reduced. Those twos can go into each other and it would just be HF. And then P4H10, is this already simplified? No. Oh, I'm sorry guys. That is molecular because it's not reduced. So not reduced, not reduced, not reduced. These, oh wait. Okay. These were the only two that were already in empirical. I'm going to leave these for you guys to do on your own. Okay, I just want to show you how to do it on this side. Okay, so the ones that down here it says write each of the molecular formulas and the corresponding empirical. So let's write the ones that were not reduced. So C2H6 will become CH3. Okay, this one down here was molecular. H2O2. What is now that going to become? HO. Okay, and now when we go and look at reduce the other molecular, H2F2, what is that going to become? So that's going to be reduced to HF. So now it's at the empirical formula level. One more example, and the other half are for you, the P4H10. So when I'm reducing or simplifying, I'm using those words interchangeably. I'm just asking myself what number can go into both of these to get to a smaller number. So for this one, it's 2, so 2 goes into 4 how many times? And then H goes into 2 goes into 10 how many times? So that's what you're going to do for the molecular ones. The empirical ones are already simplified. They're already reduced. The rest of the front of this worksheet, this bottom half, this is just an example of walking you through, okay, the empirical. But let's go ahead and try one. Flip it around. If you need to pause the video to write down the steps at the very top, you can. So here we're calculating the empirical formula. The first step is the percent is the grams, okay? And there's no room on this paper, and there's no room on your paper either, so you're going to need to grab some scratch paper. So 83.7% carbon and 16.3 percent hydrogen. Okay, according to step 1, we just changed the percent to grams. So 83.7 grams of carbon, and this is 16.3 grams of hydrogen. That was step 1. Step 2, convert grams to moles. That is with the T chart. And the template is on the board, what you're supposed to follow. Whatever you're given goes where? In the top left-hand corner. Okay, and whatever unit this is has to match here. So the more you practice this, the more you do it, the better you're going to get at it. And what am I looking for? I'm converting grams to moles. So a mole goes here. Now right here, where am I going to get this blank here? If it says grams, I'm automatically going to look to my periodic table, and I look for the mass of carbon. That's what we're looking for. Carbon is right there, 12.011. We'll do hydrogen in a second. Let's just finish this one out. So am I going to multiply or divide? If it's side by side, you multiply. If it's top to bottom, you divide. So 83.7 divided by 12.011. That gave me 7 moles. Okay. Now let's get the moles on the other side. I'm going grams to moles here. Whatever number I was given, right here, goes in the top left-hand corner. If this is grams of H, this has to be grams of H. Whatever you are looking for, solving for, is the top right-hand corner. Again, if it says grams of hydrogen, where am I going to find that? Periodic table. Am I multiplying or dividing here? Dividing, so take 16.3 divided by 1.008. So that gave, oh, I forgot to include my unit of just C. It's just very important with all the numbers and everything. Always keep your units. So this gave me 16 moles of hydrogen. According to step 3, which is way up here on your paper, it says from step number 2, whichever is the smallest mole, that's what's on the denominator, and you divide. Okay, so which one's smaller? This one. So that will be on the denominator for both. But then you divide the answer. So this 7 divided by 7 is 1 for carbon. This 16 divided by 7 is 2 for hydrogen. Okay. Now, according to number 4 at the very, very top, it says that is now its subscript. So C1H2. This is the empirical formula, CH2. Again, you don't need to write the number 1 because it's obvious that you already have a number 1 or one of the molecules because the C is written. So CH2. Okay, so that's how you do these up here at the top of your worksheet, the empirical formulas. I'm going to put this here for a second and zoom out entirely. And if you want to pause it, write down the steps. The last step, number 4, is now the subscript. Whatever you get after you're done dividing is now the subscript. So that's calculating empirical formula. Let's do an example from the bottom half of the worksheet. If you want to pause it and write down the little notes I made. So in these we're going from empirical formula, you're given an empirical formula, and you're going to turn it into the molecular formula. The formula for that is you take the molecular molar mass, which just so happens to be given to you right here, and divide it by the empirical mass. They give you the empirical formulas, but not the mass. So step 1 for this is going to be find the empirical mass. I'm going to do this on an extra sheet of paper as well. So we're finding the mass for P2O5. So I go to my periodic table because you see the word mass. P for phosphorus is 30.9 grams, but I have 2 of them. Okay. Oxygen, the mass is 15.99, but I have 5 of them. So I'm going to type this in my calculator. 30.9 times 2 gives me 61.8. 15.99 times 5 gives me 79.95. I need to add these together to get the total mass of this formula, okay, of this compound right here. 79.95 plus 61.8 equals, the total mass of P2O5 is 141.75. So I'm going to use that. I'm just going to write it here just to help me. And now I'm going to go back to the formula, which is right here. So step 2, plug it into the formula, which is the molar mass. Let's go like that. Molar mass divided by the empirical mass. Okay. The molar mass is right here. They already gave it to us. So that's 283.9 divided by the empirical mass, which we just solved for, which is right there. 141.75. You plug it into the calculator. It gives me 2. Okay, what do you do with that 2? And the last step, multiply your answer from step 2. Multiply your answer from step 2 to the subscripts of empirical formula. Let me scoot this up. So here's our answer from step 2, and I need to multiply it to the subscript. So originally, the empirical is P205. I'm going to multiply this 2. So it's P4010. That's the final answer. I'm going to zoom out. If you want to pause it to write all the steps. And we will continue tomorrow.